Hello everyone, my name is Shahim, and in this video I'm going to compile a custom Linux kernel for IMX233. So basically IMX233 is an SoC from NXP family, and I just selected this IC because it is really cheap and easy to use. So first, take a look at IMX233 board. And you can go to the Olimex website. And I just selected the cheapest version, IMX233 Linux Micro. I mean, all these boards are have the same SoC chip, but their peripherals and also their IOs are different. So, but in my case, is the right-hand side. So this board is pretty simple. It just has the SoC, and you can see that the SoC, the SD card is directly connected to the SoC. We have a input power jack. It is 5 volt, and then we have a USB connectivity. We have an AV output, just bunch of push buttons to reset, power, and recovery. And as you can see on bottom left-hand side, we have 4 pins, and these are actually connected to the UART0 and used for a debugging and SSH. And on the other side of the board, we just have a simple 64 megabyte SRAM, and it is just like 2-layer board. Feel free to design if you are interested. It's a open source design, so you can actually see all the information from the Olimex website. Go to the user manual. If I go downward, probably at somewhere at the middle, we have, and then we have the main SoC design. Yep. So here we have a SoC, and it's just like connected to the SDRAM. And then we have a GPIO output, and here we have a SDRAM, which is directly connected to the SoC pins. It's enough about the hardware because the intention of this video is not about hardware, it's most likely about the software. So let's back to our main topic, compiling a Linux kernel for the IMX233. So just run your virtual machine. In my case, it's an Ubuntu. We just downloaded the Pocky from Yocto project website. Go back to my first tutorial. I have a full tutorial on that topic. So as you can see, we have just main meta layer. But for the IMX board, we need some BSP layer to support the NXP SoC device. So we go to the internet and then search for meta layer Freesql. So Freesql is a semiconductor company which is bought by NXP in 2015, I believe. And we need their GitHub page. So GitHub page, Freesql, that's it. I would recommend go back to the main web page, github/Freesql, and go to the repositories to see all available repositories from the Freesql. Some of these repositories are labeled by Bitbake, and this is actually what we need. Meta Freesql. The second one is Meta Freesql distro. So you can see that the layer containing NXP hardware support metadata. So this is actually what we need. The second one is BSP layer for Freesql's ARM-based platform. And this one is also tagged by Bitbake. But when we go to the description, I mean, this layer actually provides the machine learning application and software for the NXP machines. But I mean, we are not going to download this one right now because we are not actually going for machine learning part. So the second one is the Meta Freesql third party. This one is also tagged by bitbait. I mean, these three would be enough for us. I mean, feel free to search other layers as well. For example, Meta FSL ARM. So we can go, okay, we can see that Qt5 and Qt4 are provided in this layer. So if you are interested to compile the Qt4 and 5 in your Linux image, so you have to download at least these two layers or these two recipes or this layer as well. Or if we go to the graphics, for example, so GTK package is available on here. Xorg server is available here, but in our case, we are running a very cheap IMX device, which is only has 64 megabyte of RAM, and we are not going to run the X window on that. So just let skip the whole Meta FSL ARM, just like downloading these three layers. So as I mentioned in my first tutorial, so metadata and meta layers should be compatible with the POKey that you have downloaded. We previously downloaded branch Donful from the Yocto project. So all the metadata should have the same tag and same label. Go to the branch and then select the Donful. So in that case, we actually see all file that is provided for Donful branch. Go to the code. You can actually download it by zip, but in my case, I just like use the terminal to do that. Terminal, go to the desktop, cd desktop, POKey test. So cd POKey, and then I copy the address. So git clone. Make sure that you are selecting the correct branch -b Donful and hit enter. I will download the first one, just like remove this one. Make sure that the distro has the same branch, Daisy, Danny, Donful. So the second one, and the third one, let's see if it has a Donful branch. Yeah, Donful branch is available. Go to the code, copy the address, go back and paste it. So as you can see, we downloaded the Donful branch. Okay, that's everything. Let's close all the package. So all of them are available. Let's back to the POKey. And as you remember, we don't have the build directory. What we are gonna do is to print source OE. So it just provided the build directory for us. We go to the conf. We have to add our new layers to this file. Go back to the POKey. So this is the first one. Copy the name. Freesql, copy the name. And distro. And added the third party as well. So the order doesn't matter. So you can just paste it which order you would prefer. Complete the pass. Okay, first one, second one, third one. So as you can see, we have to use / at the end of the. The next step is to select the correct machines. Go to the local conf. So as you can see here, we have several machines, but we have to add our own IMX port. So let's comment this line and then add the correct machine. You can remove this. So how you can find the correct machine name? Go back to the Pocky folder. We just downloaded the Meta Freesql. Go to the directory, then go to the conf, then go to the machines, which means that which machines are supported by these layers. So you can see IMX6, IMX7, IMX8. Okay, we have IMX2, 3 EVK. So this is a very good option to work on. So let's open it up. So actually, as you can see, this machine is work for a IMX2 3, and we can actually use this machine for our work. But we can also investigate a little bit more. Go back to the Pocky. This time, go to the Freesql third party. Go to the conf, machines. The Meta Freesql third party provided some SoC machines for us as well. So as you can see here, they have provided a machine for IMX233 Linux micro. So this is exactly what is our board name. So instead of going back from the scratch and compiling the IMX2 3 EVK, we can use this machine. Probably they have added some configuration based on our board. So you can either select the first one or this one. I just copied the machine name and then open up the local conf and added our machine here. Save. Let's see if we can change anything else in here. So, I mean, package class. So this is actually when the Yocto is trying to compile the packages for you. You can actually use the RPM packaging or IPK or deb files. What else? Because we are using the Freesql meta layer, we have to accept some license. So you can go to the Freesql website and see what are the license. We can just add and accept the Freesql license, accept FSL EULA to 1, which means that we accept the license, save the file. Then we have to open up a terminal and print bit big core-image base. We can use another config to compile the kernel, but for now, we will stick to the core image base. Hit the enter. What? Okay, some error on here. Let's find out what is the problem. Config localconf. So as you have seen, there is some problem with the machines. Probably I didn't put it into double quotation. Yeah, correct. That's it. Okay, parsing the recipes, read all the recipes and see which package should be run first, which should be run after another. It takes a while. Let's see how long does it take. So the Bitbake have to download all the packages and it takes so long. But in my case, I have installed all the files and everything in my computers, so there is no need to wait so long to be able to compile the files. Just let's see if it is making any error or not. No, it just take a couple of hours and then the Linux image will be generated. But for now, let me just stop this process and then go back to my main Pocky. Then you have to open up a new terminal. And same as before, print source OE, and then bitbake core-image-base, hit the enter. Let's see how long does it take for me. So I have most of the packages. Okay. So it is doing the rootfs. It's creating the root file system for us. So do image Vic. Actually, it will create a image for our SD card. We will go through that. Just remember the name Vic, W-I-C. And that's everything. That's done. Go to the Pocky, build, temp, deploy, images, and then IM export. So everything would be available in here. So let's look at the generated files. So the first file is core-image-base.env. Let's open it up. This file basically tells us about the image that we have generated, which layers that we use. So what is the boot file name, uimage, and imx233 DTB are our boot image file. DTB means that the device tree file. Some of them are linked. So the rootfs is stored at this location. And we can go through the file and see. So uimage and DTB are the booting file. And then we have a uboot.sp. So this is our uboot. What we can do is that we can manually partition the SD card and put all these image, uboot, and DTB in the correct partitions. But as you remember previously, we have generated .vic file. So vic file is the SD card image. So we can just burn these vic file into the SD card, and that would be everything for us, instead of partitioning by ourselves and then putting all the file in the correct partitions. So I just connected the SDRAM reader. So I'm going to use it on my virtual machine. Hit the enter. Okay, it's connected. Let's see the drive. So you can use disk software in the Ubuntu and see all the mass storage devices. So this is my this is my SD card, and it is empty. And the device name is devsdb. So what I'm gonna do is that I will first double click on this vic file. So let me just extract this file. It is around 141 megabyte. Oh, so the vic file should be extracted somewhere around here. So I have to open up a new terminal, go back and then open terminal. So first, let's see our SD card using the sudo fdisk -l sd dev sdb. So as you can see here, this is our SD card. It doesn't have any partition. And so I'm going to burn this VIC file into my SD card. Let's see the VIC file once again. And then output file is equal to dev sdb, and bs is equal to 1 meg. High flag equal to full block. And hit enter. It takes a while because it actually burning the VIC file into the SD card. Okay. And then we can see that two partition is appearing here. We can use sudo fdisk -l s dev -sdb, see all the partition. So basically 3 partition are generated for us. The first one is on track DM6 AUX3. So in this partition, basically the SDB, I mean the uboot.sb file is burned. In the second partition, which is in the FAT format, the U image, where is the U image? U image and the file with .dtb device tree is copied. And the third one is our rootfs file. We can actually look at the boot U image and imx.dtb copy, and then on the root we have the rootfs file system, users, lib, everything in here. Yep. So the next step is to just running the SD card into the IMX board and see if it is working correctly or not. Eject. I can go down. So this is my IMX board, and I just connect a USB to serial adapter. Then I will connect the USB port into the computer. This time I'm going to use my host computer. And then I need a software named PuTTY. So go to the serial connection type. My USB dongle is on COM3. Change the speed to 11.5200. Open a port. So I'm going to power on my board and let's see what is happening. Okay, the U-boot is on. The kernel is working. Reading the rootfs file. Let's see what is actually happening. Yep, it is boot up. It asks for the login. I hit the root, and yep, the Linux kernel is up, and you can use whatever you want. I will use uname-a to see the kernel version. So basically, we are using the Linux kernel 5.4.17, January 17, 2022. Yep. So in this tutorial, we learn how to compile the Linux kernel for our IMX board, but you can just change the machine name to whatever machine you would prefer. Similarly, for the Allwinners product and also Rockchip product, they have the same process. You have to find the correct metadata and just run the bitbake. Thank you for watching.